Here is the next set of notes for Module 2. This is the All About Functions notes. Keep in mind that the last example of the zeros notes had a calculator example. I will do that example with you guys in class so that I can actually demonstrate that for you. This lesson's quote is, "I'm a great believer in luck, and I find the harder I work, the more I have of it," by Thomas Jefferson. Working hard in this class is going to be extremely important. Now, in the first part of this set of notes, we're just asked to evaluate functions. Now, when you're asked to evaluate a function, essentially all you're doing is plugging in a value. Okay? Now, in terms of notation, when you see something like f of 0, remember that that means your x value is equal to 0. So we're plugging in an x of 0, and we're going to see what we get out. Okay? So f of 0 would equal 6 times 0 minus 0 squared. Okay? 6 times 0 is 0. 0 squared is 0. So we essentially have 0 minus 0, which equals 0. Now, this didn't necessarily make a huge difference in this example, but notice that when I plugged in, I put parentheses around that value that I was plugging in place of my x. That's going to be super important when you have negative values, so it's good to just get into that habit of doing that all the time. Alright, next we have f of 2, so it means my x value that I'm going to plug in will be 2, so it's going to be 6 times 2 minus 2 squared. Okay? 6 times 2 is equal to 12. 12 minus 4 is equal to 8. So f of 2 is equal to 8. Okay. Now, question C asks us for f of negative 2. This is going to be one of those examples that it's really important to use parentheses to make sure we get the sign correct in our final answer. So the x value we're plugging in is negative 2. This is going to be 6 times negative 2 minus negative 2 squared. So be really careful of those signs there in the middle. 6 times negative 2 is negative 12. Now my subtraction is still going to carry down, and then I have to square negative 2, which will give me a positive 4. So this is like negative 12 minus 4, which equals negative 16. Now, in these next two examples, D and E, our answer is going to just be a simplified expression. In A, B, and C, we were able to give an exact answer because we were plugging in a specific number. But notice here that we're going to be plugging in expressions like the quantity x plus 1, so we're also going to get out an expression as our answer. So, if I plug in the quantity x plus 1, I'm going to have 6 times the quantity x plus 1 minus the quantity x plus 1 squared. Okay. Now, on 6 times the quantity of x plus 1, we're going to need to distribute. That's going to give us 6x plus 6. Okay. My subtraction will say subtraction. Okay. And now you have to be super careful about what you do with this quantity x plus 1 squared. The quantity x plus 1 squared does not equal x squared plus 1 squared. So make sure you don't fall into that trap. Okay? You need to make sure that you FOIL this out. X plus 1 squared is like the quantity x plus 1 times the quantity x plus 1. When we FOIL that out, we're going to get x squared plus 1x plus 1x plus 1. And that's going to simplify to x squared plus 2x plus 1. So when you see a binomial square like that, you have to make sure that you FOIL it out. So remember, I copied over my subtraction symbol, and now I'm going to be subtracting that entire quantity, x squared plus 2x plus 1. This is another example where it's really important to make sure I'm putting parentheses around that quantity that I'm plugging in, otherwise my signs might get off. So let's go ahead and distribute that subtraction sign now through that trinomial at the end. I'm just going to copy over 6x plus 6 and I'm going to have minus x squared minus 2x minus 1. Now, if I look at all those terms, there's going to be some that we can combine together, and I'm also going to go ahead and write my answer in descending order. So if I look for my x squared terms, there's only one, so I'm going to write my minus x squared in the front, keep that sign with it. Now if I look at my x terms, I've got a 6x, and I also have minus 2x. So 6x minus 2x is going to give me a positive 4x. And now if I look at my constant terms, I have a positive 6 minus 1, and that will give me plus 5. So when you evaluate f of x plus 1, the resulting expression is going to be negative x squared plus 4x plus 5. Okay. We've got one more where we're going to simplify an expression. This time we're looking at f of negative x. There's a negative in there, so again, it's going to be super important to make sure we're using our parentheses. So we have 6 times negative x minus negative x squared. Now 6 times negative x is just going to give us a negative 6x. My subtraction is getting copied over, and now when I square that quantity negative x, I'm going to get a positive x squared. None of those terms can be combined because there's no like terms, so that would be my answer right there. I'm going to go ahead and just rewrite it in descending order. So this would be negative x squared minus 6x. So f of negative x equals negative x squared minus 6x. Now this next example is going to be very similar to example D that we did previously, but I'm going to change the function on you guys. This time we have f of x equals x squared minus 3x plus 1, and I'm looking for f of that quantity 2x minus 1. So everywhere I see an x in my original f of x function, I'm going to replace it with a 2x minus 1 in parentheses. So this will equal the quantity 2x minus 1 squared minus 3 times the quantity 2x minus 1 plus 1. Now, remember I mentioned before that when we square a binomial, we have to make sure we FOIL it out. So 2x minus 1 squared is like 2x minus 1 times the quantity 2x minus 1. Okay. Let's do that out over on the side here. So we have 4x squared minus 2x minus 2x plus 1. And that will combine to 4x squared minus 4x plus 1. Okay, so that means at this point we have 4x squared minus 4x plus 1. I'm going to go ahead and distribute through this 3 minus 6x plus 3 plus 1. Now we've got some like terms we can combine here. There's only one x squared term, so I'm going to copy over my 4x squared. If I check out my x terms, I have a minus 4x minus 6x, so that will give me a minus 10x. And if I look at my constant terms, I have a 1, a 3, and another 1. So that's going to give me plus 5. So f of the quantity 2x minus 1 is equal to 4x squared minus 10x plus 5. Alright, this time we're going to look at a graph and answer a series of questions about it. Some are going to be evaluating just like we looked at, but from a graphing standpoint. Others are going to tie in some of the topics we've already talked about, and a couple questions are going to bring in new ideas as well. Notice that this graph does have a vertical asymptote, that red line, okay? So it's going to get, the graph itself will get closer and closer and closer to that x equals 1 value, but it never actually touches it. So the first question is, what is or are the x-intercepts of g of x? Now, an x-intercept occurs when my y value is 0 or when it crosses the x-axis. It's two different ways of saying the same thing. Okay? So I'm looking at this point here, and I'm looking at this point here, and I'm looking at this point here. So that means I'm going to have 3 x-intercepts. Okay? Now, they tell me here to give my answer in coordinate form, but it's super important for us to realize that anytime they ask me for x-intercepts, I will always give it as a point. Okay. We discussed this in the last set of notes, that if they ask me for a 0, it's just the x value, but if they ask me for an x-intercept, I need to give that whole point. Okay. So, let's see, we've got -7, 0, that's an x-intercept. We have -3, 0, that's an x-intercept, and we have -1, 0, that's an x-intercept. Now, the next questions ask us to evaluate numbers on this graph. So, if I'm looking for g of -3, remember that this -3 is an x value. So it's asking me, when x is -3, what is my y value? So if I check out this graph, when x is -3, my y value is 0. Same thing here, but now I'm looking for an x of 3, and I'm looking where my y value is. So when I come over here and look at an x value of 3 and trace it down to the graph, I see that I have a y value of -2. So g of 3 is equal to 2. Now this next idea is something that we haven't talked about yet formally. We want to know if g of 0 is positive, negative, or 0. Now one way that we can do that is by going to that x value of 0 and seeing what my output is. If I go to an x value of 0 and I follow it down to the graph, I'm going to see that I end up at -3. Well, actually, we need to blow up that graph to be a little more accurate. We're actually at -4. It's easier seeing that previous graph that's a little bit bigger. So g of 0 is equal to 4. So, since g of 0 is equal to 4, 4 is a positive number, we know that g of 0 is, rewind on me, beep, 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 beep. G of 0 is -4. Remember, we went down on the y-axis. Those numbers are negative. So, we know that our answer would be negative. Okay? Now, another way of thinking about this is, if you go to g of 0 and you see that it is below the x-axis, without even figuring out that value, you know that it's negative. So below the x-axis will always give you negative. If we went to it and found that it was above the x-axis, it would be positive. So you can go ahead and evaluate and figure out what g of 0 equals, or you can ask yourself, okay, is this below the x-axis or is it above the x-axis, to figure out if it's positive or negative. Now, the next question asks us, how many times does the line y equal 2 intersect y equals g of x? So if I look at the line y equals 2, I'm talking about this line going across that passes through that y value of 2. Now, if I look at the graph, it actually intersects it twice. Once here, and once right here. Just touches it. So how many times does it intersect? It intersects twice. And the last question on this slide is, for what value or values of x does g of x equal 5? So notice this time we don't know what the x is. That's what we're trying to figure out. But it tells us that the y value is 5. So when we look at our graph and we go to a y value of 5, right here, and we follow it over to our graph, and then back down to the x-axis, we find out that the x value is -8. So it's really, really important when you look at these questions to pay close attention to what piece of information they're giving you. okay? If they give you the value, like they did in the first question, like 0, that's our x value. But if they give you the value of what it equals on the outside, that's your y value. So pay close attention to what piece of information they give you. Give the intervals of x such that g of x is greater than 0. Use the union symbol between multiple intervals. So anytime we have more than one interval, you always want to make sure you're using the union symbol. So that should just be second nature to you. They ask us for when g of x is greater than 0. If something's greater than 0, another way of saying that is that it's positive. Now on the last slide, I mentioned to you that when the graph is positive, it means that it's going to be above the x-axis. Okay? So if I check out my graph over here on the left, I have this portion that's above my x-axis. I have this little hump that's above my x-axis, and that's it. Everything else is below my x-axis, which would be negative. So when I write out these intervals, I have negative infinity to negative 7, union negative 3 to negative 1. Notice that when I'm writing my negative 7, my negative 3, my negative 1, I'm looking at my x values. Give the intervals of x such that g of x is greater than 0. A common mistake here is students start to convert over to y values. You've got to make sure that you're using your x values here. Now, the next question asks me to give the intervals of x such that g of x is less than 0. So when we say that it's less than 0, we're really saying that it's negative. Okay. So now, rather than looking above the x-axis, we're looking below the x-axis. So we're looking at this dip in the graph here. We're looking here. And we're also looking at that right-hand portion as well. Now, remember we got to work around that vertical asymptote. So our intervals, remember we're in terms of x, we'll start at negative 7, we'll go to negative 3, union negative 1 to positive 1, and then we have again 1 to infinity. Now, another question that I get sometimes about intervals of x where something's positive or negative is why I used parentheses and I didn't use brackets on some of these numbers. Anytime you are talking about an interval where a function is positive or an interval where a function is negative, you will always use a parenthesis. And that's because negative 7 isn't actually included. At negative 7, the graph is 0. It's right before or right after that it's positive or negative. So anytime you're asked about intervals where the graph is positive or negative, you will always, always, always use parentheses, not brackets. Okay, now we're going to look at the function r of x equals the quantity x minus 6 over x squared plus 2x. I'm going to rewrite that for us. So we've got x minus 6 over x squared plus 2x. Now the first question asks me for what values of x does r of x equal 0. Now remember that we're looking for the x value and that my y is going to equal 0. We got to pay close attention to what piece of information they give me. So essentially I'm saying that 0 will equal x minus 6 over x squared plus 2x. Now, something cool about rational functions like this is that anytime you set a rational function equal to 0, it will equal 0 when the numerator equals 0. So you essentially get to ignore the denominator. Okay? So check this out. Will equal 0 when numerator equals 0. So I'm not even going to worry about that x squared plus 2x. See ya! All I'm going to worry about is when 0 equals x minus 6. Now to solve this, I would just add 6 to both sides, and I'm going to find that 6 equals x. So for what values of x does r of x equal 0? For the x value of 6. Alright, same function. We're still looking at that x minus 6 over x squared plus 2x, but now we want to figure out for what values of x does r of x equal negative 1/5. So we're still looking for that x value, but we know that our y value is going to be negative 1/5. So we're going to say negative 1/5 equals x minus 6 over x squared plus 2x. Now, unfortunately, I can't just ignore my denominator on this one, okay? That trick only works when I'm looking for r of x equal to 0. That's when I can just set my numerator equal to 0. Now I'm looking for r of x equals negative 1/5, so I've got to use all my pieces. Now, in this case, notice that you have a fraction equals a fraction. We can use cross multiplication to solve this. So I'm going to do negative 1 times x squared plus 2x, and that's going to give me a negative x squared minus 2x. Make sure you give that negative to both pieces there. And I'm going to go the other direction as well when I cross multiply, and I'm going to have 5 times x minus 6. Remember that that 5 goes to that entire quantity, so that's going to equal 5x minus 30. Don't just give that 5 to one piece, give it to both. Now, in order for me to solve this, I need to get everything over to one side and have it equal to 0, but I'm also concerned about the fact that I have a negative in front of my x squared, so I want to make sure that that term is positive as well. Okay, so what I'm actually going to do in this example, and this is not like me because I typically put all my stuff over to the left, is I'm going to move all my terms over to the right. But I have a reason for doing it this time. It's because I want that x squared term to be positive. So when I do move my x squared term over to the right, it's going to become a positive. And when I move my negative 2x over to the right, it's going to become a positive. That's going to leave me with nothing on my left-hand side, so it's going to be a 0. 0 equals a positive x squared plus 2x. My 5x stays positive, and my 30 is still going to be subtracted. Now, I can put together that 2x and that 5x. 2x plus 5x is going to give me a 7x. So now at this point I have 0 equals x squared plus 7x minus 30. I'm real close. We got to finish off by factoring. So that trinomial is going to break down into two binomials. What can I use that would multiply to 30 but adds to 7? Let's try 3 and 10. And we're going to have a negative 3 and a positive 10. And my x squared is going to break down into x and x. So now I'm going to use that 0 product property and set each piece equal to 0. So I have 0 equals x minus 3. And I have 0 equals x plus 10. When I solve each of those, I get x equals 3. And I get x equals negative 10. So for what value or values does of x does r of x equal negative 1/5? We get two values in this case. We have an x value of 3 and we have an x value of negative 10. And that's the very end of Module 2. When we come back together in class on Thursday, we will start Module 3.